Hey everyone, this is Mayur. Welcome back to MLOps. In this video, we'll discuss what is Metaflow and its integration with different tools. And then we'll try to set up Metaflow locally and then run few flows in Metaflow. So this is the setup that I'll be doing on Ubuntu, and most of the steps will remain same across the OS. So you can try to set up by following the documentation. And with that, without wasting any more time, let's get started with what is Metaflow. So it is a tool that will help you to build and manage ML projects end to end. When I say end to end, I mean the Metaflow is capable of doing data collection, data transformation, model building, model deployment, and then monitoring the same, and also versioning the data and versioning the model. So it is capable of doing all the things that is required for an ML project. Now in this video, what we'll do is we'll understand how this Metaflow works with different integrations, how it is advantageous or how they utilize, how they utilize different tools. We'll understand that, and then we'll set up Metaflow, and then we'll run few flows. So when it comes to setting up Metaflow, you can directly use a specific stack that is available, open source stack that is available for Metaflow. By doing that, you will be able to run a bunch of tools that are required for running Metaflow, which includes, this includes Docker, Minikube, Helm, and other tools. But let's understand the few key tools that we need to understand what will happen when Metaflow is running. So when you're trying to install Metaflow in your machine, in the backend it will install something called as MinIO, which is similar to an S3 bucket. It is used for storing Metaflow's artifacts and logs and providing scalable and cost-effective alternative for Amazon S3. And so as I said, it does provides features like DAG visualization, artifact inspection, and versioning. That's why it is connected with MinIO. And since it is a flow or a pipeline, Metaflow, whatever the flow that you create, it's a pipeline. So you have something called as an Argo event, which is another tool that gets integrated with Metaflow that will try to help and create and publish events that can trigger Metaflow's flow, inside Argo flow. It is kind of allows a dynamic triggering of workflows based on external events or completion of other workflows. Now there is something called as Argo flow. Since you are trying to build a system for production, you want to ensure that it can be scheduled, the work can be scheduled. So you can use Argo flow for that, which will help us to schedule the Metaflow's flow run. And there is Postgres and metadata services. These are nothing but tools for storing the information about various operational data the Metaflow has, and ensuring there is tracking of runs, reproducibility or discovery of data science experiments and production workflow. This is something called as you generate run IDs, and whatever the metadata that was used for that, and everything can be managed through Postgres and metadata services. These are 5 important tools which gets integrated with Metaflow while you are running any experiment or trying to run. This is basically for locally, when you are running it locally. When you are trying to put it in production, there are other tools that can be utilized as well. So with that, what I'll do is I'll move on to the setup part of Metaflow. So I have already set it up. Docker is required, Minikube is required, Helm is required. And there are a few other tools are required, which I'll talk about. So first thing is you have to create the Python virtual environment, which is using this command you can do, and then activate that environment using source metaflow-environment name followed by button activate. So this will activate the environment for you. Since I have created it, so I'll just directly switch to that environment while we are trying to do the practical implementation. So once these 2 commands are executed, what you can do is once you run this command, this will switch to the Metaflow environment. Now inside that environment, you can install Metaflow. Okay, this will run the Metaflow. This will install the Metaflow inside this environment, Metaflow-env. And once that is done, you can do something called as Metaflow-dev up. Okay, as I was talking about a stack, right? Open source stack that is available for Metaflow. So when you run this step, Metaflow-dev space up, it will try to install all the packages that are required for Metaflow to run in local machine. Okay, so what will happen if you see here? I'm not sure if you're able to see the screen. So here you will see, once you do that, okay, it will check for Docker is present or not, and then it will try to install certain libraries like Gum, and then it will try to install Minikube, it will try to install Helm and other tools that are required to run. Okay, so if you see here in this image, okay, you will see preparing Kubernetes, and then it will look for Minikube, cluster is ready, Helm is ready. Helm is for what? Installing the packages. It's a repo for installing packages into Kubernetes environment. And then it is installing Tilt, which is again a way of what managing Kubernetes cluster. Tilt is used for that. And then if you see by the end, what you see is select services to deploy, press enter to select all. So it will allow you to, it will ask you, okay, what are the different services that you want to install in your Metaflow. So it is min.io, metadata services, Metaflow UI, Argo flows, and then Argo events. So what I will do is, so I will click enter and I will install all the 5. Okay. And what will happen is, if you see here, select services to deploy, no services selected, deploying all. This is the next image. Okay. And it will deploy everything. And what will happen is, it will then start running the Tilt module, which is running on localhost 10,350, which is the where your Tilt is running, and which will be showcasing all the different modules, right, which gets installed, like min.io, metadata services, UI, Argo workflows, Argo events. Everything will be shown here because it's kind of a managing tool, right, which will manage the Kubernetes pods or Kubernetes cluster. Okay, we'll look into that also. Okay. So we'll see some of these we can see, because since I have already installed, some of these we can see, and some of this you have to try it out on your own. Okay, and see, once this is done, you will see all the different parts that is up and running. You will see Argo event control manager, Argo events webhook, workflow server, workflow controller, then event bus, then Metaflow services, Metaflow UI stack. Then you have min.io, and then Postgres. So you have all these pods running just by doing one command, which is Metaflow dev up inside the Metaflow environment. Okay, so all these things will run up and running once it is done. And there is corresponding services. Okay, this is the pods, okay, where the applications are running, and there is Kubernetes Check services, which is how you will communicate with those applications. Okay, these are the applications. So these applications can be communicated through Kubernetes services, and these are the services for those applications. Okay, so if you want to use these application, okay, you want to go through these services. Just keep that in mind, because that will be helpful in understanding certain aspect of running Metaflow UI. Okay, so coming to the issues that I faced while trying to run this specific setup is, there were certain packages which were unable to install. For example, this install Gum was there. If you see at the earlier stage, I showed here installing Gum. Okay, there is a statement called as installing Gum, and it was throwing an error initially. So it was because of certain packages that I was having in my system. Okay, so I had to remove them, and then it started executing. So this was the issue. Okay, and to overcome that issue, we removed couple of repositories, okay, Pulse FX and Simple Screen Recorder, and then we updated all the packages. So this will resolve this specific issue. Okay, now what I'll do, right now, till here I talked about certain issues. Now what I'll do is, there are certain other more issues that we resolved. Okay, we'll talk about that later. And now let's go to the UI, not the UI, the terminal where I'm running this specific Metaflow, right? So as I said, I hope you're able to see this specific command, source Metaflow environment dev activate. So this will activate my environment, and then I'm doing Metaflow dev up. So I'm running up that stack that I talked about, which contains Argo workflow, Argo events, MinIO, Postgres, Metaflow UI, everything, right? So it will run all those. So first it is checking for Docker daemon, Docker is running, Gum is installed or not, and then Minikube, setting up the Minikube cluster. So all these things are running. Okay, so finally what will happen, right? If you come here, it will look for, as I said, we have to select the services, then we enter, then it will deploy all the services. Okay, and then these services can be viewed in tilt because it is the part that is managing your Kubernetes cluster. So the reason why I executed this command earlier is because it takes time to run everything. Okay, that's why it takes around 5 to 10 minutes for running these. Okay, so at the end what we are seeing is here once I start services, tilt is starting, then it will ask for password. Okay, and then it will spin up the Minikube cluster and it will check for errors if there is any, and you will see still getting hosted on localhost 10.350. Okay, if I go and click this one, it is already there, up and running. So here you will see localhost 10.350, and then this is the overview file. And if you see here, let me refresh this one. So there are 13 services that are up and running where the health checks are done. Okay, so there is Argo events, Argo workflow, metadata service, Metaflow UI, MinIO, Postgres, unlabeled service, and there is tilt file. Tilt file is what is running in the backend, okay, which contains all the information about the different applications that you are running, which is nothing but your MinIO, okay, Postgres, metadata services, and then you have Argo workflow, Argo event. So all these are getting executed because of the tilt file here, and it is located in my specific location. Okay, so what will happen, right, when you are doing metaflow-dev up, it will try to run this tilt file. It will install all the packages, that is the components to install, and then it will also run tilt file, that is the tilt application, okay, service, and it will run on the specific port 10350. Okay, so here we have everything up and running. So next what we'll do is, so we have talked about what, let me go to this documentation, right? So we talked about setting up. So there are various steps we have taken to make it running. So let me go to this one also, right? Let me show you again. So what are the different pods that are running? kubectl, get pods. So you will see all the different pods that are running, kubectl, get services, all the services that are running. Okay, and you will see where the service is running. Metaflow service is running on 8080, Metaflow UI is running on 8083, UI static is running on 3000. Okay, there are other services that are running. We'll talk about that later, but these are very important now, for now. Okay, now let me go to this one. Okay, so here if you see, I have my Metaflow folder under which I have three basic flows. Okay, one is basic flow is just transferring the artifact from one function to other function. Okay, in this specifically we talk about the artifact, my variable, and then we have something called as Metaflow branch. Okay, where we are trying to run two parallel step functions or steps parallelly, okay, which is A and B. We'll talk about that. And there is something called as for each, where we are trying to run the same set of one function multiple times in parallel. Okay, so we'll do that using for each keyword in Metaflow. Now what I'll do, so here if I go to the documentation, so I'll first also look at the UI also, right? We have talked about the UI, so let me talk about UI here. So I said the UI, static UI is running on 3000. So this is the UI, and if you see, there is nothing is running right now. And one more thing, right? There is also another UI, I guess. There is localhost 8324. It's not this one. I guess 8080. Yeah. So this is one way to understand, right? Your metadata service is running or not. You can do this 8080/ping to get the response form. Okay, this will say that your metadata service is up and running. Okay, so this is good. Now what I'll do is I'll try to run a Metaflow, which is the basic one, and see if it is running or not. And I'll show you, it will throw an error, and how to resolve that error. Because if you see here, I mentioned about issue while trying to view the flows in Metaflow UI. Okay, and there are certain commands that you have to run to ensure that your flow is able to be viewed on Metaflow UI. So if you see here, I will just this is the VS Code. Let me maximize this one also. So this is a basic flow. Okay, it is a simple linear flow that demonstrates the use of data artifact. This is like how to pass from one step to other step, how the data is transferred. Each step in the flow can access the data artifact created in the previous step. The flow consists of 3 steps: start, A, and end. Start step initializes the data artifact. A step prints the data artifact, value of the data artifact, and prints the value of myvar again to demonstrate that it is still accessible. So these 3 are we are doing. These are the 3 steps we'll be doing. And from Metaflow, okay, we import the package like flow spec. This will be helping us to create the Metaflow flow. And step is nothing but your decorator, and card is a decorator. And we'll use these 2 decorators to integrate with our turning our normal function into what Metaflow function or Metaflow card. Okay. So first thing, I'll be switching to what Metaflow environment. If you see here, that is already switched, so I don't have to do anything right now. I'll just do Python, and then I'll click the basic. Okay, and then I'll try to run. So this will run. Okay, but okay, this is running, and this is running, and it is giving all the steps, right? The task is started, task finished successfully, start. This is for the another step function where the task is starting. The data artifact is hello world, it is printing. And in the third step, okay, which is end step, again the data artifact is still visible or accessible, which is hello world. Okay, and task is completed. Now this is one task that we executed. Now I want to view this flow that we did into Metaflow UI. Okay, so if I go here, I'll run this again. You will see it is not coming up. The reason being because to view that flow in your UI, you have to ensure that your services, which I talked about here, okay, the services should be able to communicate with my local machine. Okay, right now it is Metaflow service is running in Kubernetes cluster. It is not pointed to my local host. So what I'll do is I'll point it out by port forwarding. I'll point it out to local machine, and then I'll set up something called as env for Metaflow, such that it is accessible by the Metaflow service, or Metaflow, I mean. So it's a lot of thing to understand. So let me just do this. So I'll go to this specific command that I have taken here, which is kubectl port forwarding, and I'm running on it is taken from the local local namespace, default namespace, I mean. So this all things are running in default namespace, and let me paste it here. So this is the service name, if you see here, Metaflow service, and SVC is the kind of Kubernetes, and we are doing port forwarding from 8080 to localhost 8080. Okay, and this is -n default because it is running in default namespace. Okay, so yeah, one more thing, right? So it is not able to do this because I already have certain things running on 8080. If you see, right, unable to listen on port, create with the following errors: listen, bind already in use. The address is already in use. So let me clear this. So I'll do something called docker ps, and if you see, I have this one running, right? This one runs on 8080. So what I'll do is docker stop, and I'll stop this specific for docker image, docker container. So once this is stopped, then we'll try to map our service, which is Metaflow services, into the local machine. Okay, so let's wait for a moment. It won't take much time. Yeah, so this is done. Now what I'll do is I'll run the same command again. Okay, now it has port forwarded 8080 of Metaflow services to my local machine 8080. Okay, so this is done, and then what I'll do is I'll go here, I'll clear this thing which we ran. Now I'll go to the command here. Okay, I'll export this environment value. This is exported here. So this is nothing but Metaflow service URL, which is pointing to localhost 8080. Okay, this is done. Now what I'll do is I'll run another flow, and we'll see whether this is showing up on Metaflow UI or not. So let me run this basic flow.py, and then metadata service, metadata service, and then run. Okay, so you will see that it is running now. And let me go here and the UI part, right? And if you see here, it is now communicating. Okay, and now what we'll do is we'll check here. Okay, this is the localhost. Now we are able to see the linear flow. Okay, so this is what is running. Okay, it was 3 step functions, right? Start, end, and a, and the function name was, class name was linear flow. This is the flow name. Class name is the flow name as well. So let me minimize this. So you will be able to view here all the steps that it went through. Start, it took 2, task ID, it was 2, and this is task ID 3, task ID 4, and what is the task detail, right? This is the task detail. It is the function we are, this is a Python file that we are running. It is stored somewhere here, the ds root. Let me see here, right? There will be something. Okay, so here this is the timeline for what is the time taken for running each of those step functions. And then yeah, so when it comes to this specific tab, this task we are able to view. Okay, and then timeline we are able to view the time taken for each step. But when it comes to DAG, we are not able to view the DAG right now. Okay, the reason being, okay, let me show that as well, right? This is an error, not an error, this is kind of the setup that has been done by this stack, right? Let me show that. So to view the DAG, okay, you have to pull it from some kind of a storage, okay, where the DAG is already stored. So you have to pull it from there. Now it is not available because the way the Kubernetes has set up the data store for Metaflow, it is pointing to some S3 bucket. Let me show that here. So kubectl get pods, not get pods, get services, or even pods, right? Let's see what is the pod. Is it part of pod information? So what I'll do, kubectl get pod, then I'll take up this one, Metaflow UI, and then I'll do -o YAML. Okay, and here if you see, this is the point, right? Metaflow data store root, which is pointing to an S3 bucket. Okay, default store is S3 bucket, and these are some these are some locations where the Metaflow look for an information for creating the DAG. Okay. Now this is not possible right now. So what we'll do, right? We can point it to the local and then try to do it, but it's not working because I have seen already an issue that is already happening with while running it as local. Okay, I've mentioned the error here. Okay, the DAG issue. Let me copy this, open the link. So you will see Metaflow UI DAG error. The workaround, they have closed the issue without any solution. But anyway, the workaround for this is you can use the card tag to view the DAG. So what I mean by that, using the card tag. So if I go here in the visual code, you will see in the linear flow, I have mentioned card for each of the steps here. This is for basic flow. And if I go here branch, for branch flow, I don't have any card. Okay. So for each, I have a card on one of the things. Here we have for each step. Here we have for only one step. Here we don't have card itself. Okay. So let me run, right? So what I mean by this, right? What will happen when you're doing like this, when you're trying to run like this? So with the card, what will happen, right? It will try to create in a local store. It will try to save the DAG and which will get pulled and can be viewed on localhost 8324. Now let us run this one. Okay. This is the one which we executed, Python basic flow.py metadata services, and then we gave run. Okay, I'll run this again. Now this will take few seconds probably. Okay, and since it has card for everything, okay, you will see all the cards coming up when I'm trying to run this one. Card and server. So it will pick the specific whatever we executed earlier. It will pick the run, okay, and it will try to serve those as card on port 8324. So what I mean is, if you go here localhost 8324, yeah. So you will see here all the three step functions, all the three cards that we gave. We can view it here. Now this is the task code, and this is the metadata of the task. And then who was the user, what was the duration, what was the tag, when the task was started, when it finished. This was the card for this specific step function, and this is highlighted as DAG here. And if I switch it to A7, okay, this is the piece of code for this step function A, and this is the artifact, and this is getting highlighted, this is the DAG. Okay, so this is that. And then if I run it again, okay, I have to close this and then run it again to view other DAG. Okay, that is the workaround for running it locally. But when it comes to real-time example, right, with AWS or cloud services, it will automatically point to the specific S3 bucket, and you will be able to view the card, everything, right? All the DAGs can be viewed on the Metaflow UI itself. As I say, this one, I mean by this. If I go here, you will see the DAG, right? You will see the DAG coming up here. And one more thing, right? Let me show one more command where you can see the DAG here itself. Let me stop this. So to see the DAG Metaflow, instead of doing this, show. So this is the way of viewing the DAG here. First step is start, and then A, and then end. Okay, so start is again then pointing to A, and A is pointing to the end function. So this is one way of doing it. Okay, so there is another way also. Okay, so right now I didn't talk much about the flow here. Okay, let me just talk about the flow here for a moment. So this is a basic flow, and we have three step functions, which is start, A, and end, and we just move the the data artifact, which is my var, across these specific functions, all the functions. This is for basic flow. Now let's go to Metaflow branch. Now branch is, the class name is branch flow, and we are inheriting flow spec from Metaflow. Now we are creating one start function, and which is connected to two branches, which is A and B. Okay, it takes the value of 1 and it takes the value of 2. Now these two step functions will join, okay, and form combine together. Okay, these two will be combined together and stored as, they will be combined together using join. Okay, when I mean by join, this is a join. Okay, and it will give you a final result, and then that is pointing to the end function here. Okay, self.next.end. Okay, this is with respect to branch. Okay, this is you are trying to utilize multiple cores. Metaflow can execute, as I mentioned here, right? I forgot to mention. So Metaflow can execute A and B, which is the two-step functions, and use the multiple cores or multiple instances in the cloud to run these two-step functions, which is A and B. Okay, so let me run this one also right here. First, here if I just go here and then let me run Metaflow branch and .py and then metadata services. So let me run this once. So this is running, the graph is looking good. Let me go here, I'll go to home. So branch flow is up and running here, coming up. So you will see all the information for that specific flow and then the task details. Okay, so these informations are present and what is task, standard out, standard error. So all these things are coming up. Now let me just view the card right for this one. Instead of doing card server, what I'll do is card view. There is some other command, I guess, right, which we can use. Card view. Let me see what is that specific command. Somewhere I mentioned it. So one second. Card view starter, I guess. Start. So whatever, right? It is just card actually. Card server. Let's do card server itself. So now the specific thing is running. Let me go to this one, 834. Now there will be, okay, this is looking for card server, but it is not pulling it up, the specific card. Okay, that's fine. So anyway, let me just stop this one. First will be card. Is there any command that I am missing? Let me see that right here. Card view. What is the card viewer, right? Card view. Yeah, card view. Okay, this is the one. So card view, I can view specific card, which is in this case I don't have anything. So yeah, the reason, right, one of the thing I missed it here is if you see here I'm not able to view any card because none of my step function contains card decorator. That's why I'm not able to view any card. Okay, so what I'll do next is instead of running this, I will be running for each. Okay, and then I'll be running this one, run. Now what is for each? Okay, so if you see here in for each Metaflow, this is the class name, flow name, okay, which is inheriting, and this is my start function where I'm describing the titles and it is connected with a for each. Inside the self.next, I am creating a loop, for loop, which will iterate through titles. Okay, and then it will be, for each title, it will be calling this function. Okay, function is nothing but this definition, a function, and it will process each of these titles and try to create self.title. Okay, and this will be connected all the 3 times. It will call 3 times. All the 3 will be connected parallelly to the self.join using self.join. So now we can access these input. Okay, whatever we are sending to self.title using inputs. This is the keyword actually. Inputs is the keyword. So we'll be iterating through the inputs and get the title value and we'll be storing it here, self.results, and at the end we'll be joining them together. So this is the whole flow for each. Okay, this is like for running each step function, not the each step function of this one specific function A for different values parallelly. Okay, so we have executed for each here. Now it contains that card also. Now what I'll do is I'll just do card view and then I'll give the name which is start. Okay, so you will be able to view the specific card, okay, which is in this case start, and it contains the corresponding function definition here. And if you see here the final artifact, which is the title says this one list, and this is how the artifact looks like, not the artifact, the DAG looks like. In parallel, it will iterate through it will run 3 functions in parallel, which is the A, and process each of these values. Okay, so this is one way of again looking at the DAG. Okay, and then if I just do instead of card view, right, if I just do card server, so it will, if I go back to this one, this will select, yeah, there are 2 join and this one, there are 2 cards. Yeah, so yeah, we have seen a lot of things in this specific video. Okay, so let me go back here. So as I said, okay, there was DAG issue, and for which we have to either update these environment variables inside the Kubernetes from S3 to local. Okay, you can do that and make it run, and it will probably run. Okay, and then one way of again, we saw the DAG issue and we were not able to view the DAG, so we can use card server and view the DAG. Okay, so this is that. Now we talked about everything we have discussed already. Now what I want to talk about is the tilt. Okay, what it is. I'll just click this one, open the link. Tilt is nothing but a way of managing your Kubernetes. Okay, smartly rebuild everything, reservices everything. So I don't want to do anything much. I want to go to an example for tilt. Are your servers running locally in Kubernetes? Both tilt gives you smart ways to rebuild and live updates everywhere so that you can make progress. This is just an open source tool for managing your Kubernetes or any of those orchestration, right, that we are doing. Yeah. So let's understand with one example here with Python and Flask. So this is my Python Flask server that I created. This is a Flask app and it is running on 8,000. Now what I want to do is I want to just run this web server, which is Flask, into a Kubernetes cluster. So what I'll do is I'll just create a Docker build, which is the image name will be this one. Okay, and these are the Docker file actually if you want to look at. Okay, if you want me to click this one. So this is the Docker file and it is running that app which I showed here. This is the app and this is the Docker file, and then this is the YAML for deployment of Kubernetes, right, as a pod. Then this is the what it is pointing to that specific Docker image which we showed earlier and running on port 8000. Now we'll be combining the Docker, okay, Docker build, and then we'll be running the YAML. This is the tilt file. Now for initially when I showed the Argo flow and everything, this is how the tilt file will look like. Okay, I'll have Argo flow, Min.io, Postgres and everything, and here we have Docker build for what the specific example, and this is the resource. Okay, this is how you have to run a tilt file, okay, by combining all the resources. So once you do that, what will happen is it will run everything and you have to give tilt up to run it. This will start serving that specific Flask app and you will be able to view such a UI where you will be able to see your web server running. Okay, so this is basically basic of tilt. Okay, there is nothing much to learn here unless you are focusing on deployment aspect of Kubernetes and everything. Okay, so we are done with this one also, and this is what I was talking about earlier. So what are the basic flow we looked at? One is the linear flow where we are moving the data artifact, and there is branch flow where we'll be parallelly running 2 different functions and combining them, okay, using join and then end the flow. And there is for each. It will take one data artifact, run it across, it will iterate through a set of data artifact and set it to one function which is a function and join them together and end the flow. Okay, so this is what everything about Metaflow right now, okay, with respect to the setup and how to run a Metaflow flow inside a Kubernetes, which is Minikube. So with that, I'll be concluding this video, and if you have any questions while you are running this setup locally, okay, in your Linux machine or Ubuntu machine, I'll be happy to help. And if you have any issues in general with respect to Metaflow, okay, let me hit it up. Okay, thank you for watching and thanks.